So today we're going to talk about pH and pOH, which you were supposed to read about last night as you answered your reading questions. So hopefully this stuff follows along with what you read about and clarifies some of the things you weren't so sure about. Water undergoes something called self-ionization, and sometimes you will hear this called autoprotolysis. The reaction for this is you're going to take two water molecules and react them together, and what you're going to form is a hydronium ion and a hydroxide ion. So you should be able to see how this happens because we've talked about acid and base reactions before. So if this were your acid, and if this water acts like a base, then this one is going to donate a proton. And when it donates a proton, it's going to have one less. So it had two hydrogens here, and here it just has one. So then on the other side of this is going to go this way, and so you should see that this one had two to begin with, and now it has three, and that's because it accepted a proton. So that's all that's going on with this reaction. It's just acid-base, but it's just with waters. So what you need to remember is that in water at 25 degrees Celsius, when you have self-ionization of water, this is going to be true. So the hydronium ion and the hydroxide ion are going to be equal. Water is neutral, and because water is neutral, we know this about its concentrations. We know that H3O plus equals 1 times 10 to the minus 7 molar, and we know OH minus is 1 times 10 to the minus 7 molar. And we can come up with something called the equilibrium expression for water. And what Kw says, it's this formula. It's the concentration of hydronium ions times the concentration of hydroxide ions. And in chemistry, when we have a K, that means it's a constant. And in this case, in any case, a constant is a number that never changes. So for us, Kw is a value that never changes, and it's 1 times 10 to the minus 14. It is a unitless constant. Okay, it's unitless. So anytime you have a Kw, it's going to be 1.0 times 10 to the 14. One of the other things you need to know is that this number is an exact number. So it has as many sig figs as you need it to have. You could write it as 1.0, you could write it as 1.00, you could write it as 1.000. We pretty much just write it as 1 times 10 to the minus 14th, and then we don't use it when we're trying to figure out how many sig figs that we're going to need. Okay, so we're just going to use what you have so far, and we are going to try to see if you can figure out how to solve these problems. Okay, but one of the things that you'll have to remember is this equation right here. Okay, so let's talk about a solution of 0.10 molar sodium hydroxide. We've done this before to find the concentration. So that's the formula of sodium hydroxide, and you know that it dissociates in water. In the previous unit, when we did this, you would have written it like this, and then you would have split it up. So I'm going to show you like a shortcut way of doing it, because if you remember correctly, the water shows up on both sides of the arrow, and so it doesn't do anything. We just need to know that it's there. So you can also write it above the arrow, and that shows that the sodium hydroxide is in water and that this reaction is happening when the sodium hydroxide is in that water. Okay, so what does sodium hydroxide do when you put it in water? Well, it dissociates. And what does that mean? Remember, it means that it just separates into its two ions. So you would have that. Okay, now what you have to remember is that they're giving you a concentration. So you have 0.10 molar of this. Remember, there's a 1 here, a 1 here, and a 1 here. So when this breaks up, however much of this you have, you have that much of this. However much of this you have this much hydroxide. So the question says, what is the hydroxide ion concentration? And in this case, you're going to say 0.10 molar. And you get that from this equation. Okay? The next question says, what is the hydronium ion concentration? To solve for this, you're going to have to go back and use this formula. So let's write out the formula first. Let me pick up a pen. Kw equals H3O plus times OH minus, and that is going to equal 1 times 10 to the minus 14. Okay, well then let's go ahead and substitute the numbers that we know. We know that value. So I'm going to write H3O plus times, and then we found the value up here, 10 molar equals 1 times 10 to the minus 14. So you're going to plug this into your calculator. So remember, the way that you're going to plug this in is 1 second, comma, negative 14 divided by 0.10. So your screen should say, oh goodness, I always forget to pick up a pen. Your screen should say 1e minus 14 divided by 0.10. And then when you hit enter, you'll find that H3O plus concentration is 1 times 10 to the minus 13 molar. Remember, concentration, the unit is molar. And if you want to write H3O plus after this, you totally can. Now let's try another one. This time it's an acid. Okay, this time it's an acid. Consider a solution of 0.10 molar hydrobromic acid. Okay, so let's start down here because we know we're going to have hydronium ion. So we have HBr. It's going to react with water, and we're going to get H3O plus and Br minus. So remember, the piece that you care about is that the problem tells us that we're going to have 0.10 molar of this. So then how much of this are we going to have? Well, you look at the coefficients. There's a 1 here, a 1 here, a 1 here, and a 1 here. So this number is going to be exactly the same number as that number, 0.10 molar. So that is your hydronium ion concentration. There's no real math or anything to do with this. Okay? You don't need a formula really or anything like that. Okay, but to find the hydroxide ion concentration, you do have the formula. And so that is 1 times 10 to the minus 14 equals H3O plus concentration times OH minus concentration. And so you're going to plug in this value for this, because that's what H3O plus is. So when you, oh my goodness. Okay, so let's see if I can not get my slides to fly around this time. So when you solve this in your calculator, you're going to type in 1 times 10 to the minus 14, and then that's 0.10 molar times OH minus concentration. You're going to plug that into your calculator, and you're going to get 1 times 10 to the minus 13 molar for the OH concentration. And this is your answer to that part. All right, so here's one. I want you to pause it. I want you to pause it and see how far you can get with this problem. So pause the video, work it, and then start the video up again. So hopefully this is the balanced equation that you wrote for sulfuric acid. You have to remember that sulfuric acid is H2SO4. So this one's a little bit different than practice problem 1 and 2. So if I have 0.10 molar of H2SO4, I have twice as much H3O plus. So you should have done 0.20 molar for that. So after you find that the H3O plus concentration is 0.20 molar, then you're going to go back and use this formula and solve for hydroxide ion concentration. So then when you solve for Kw, you would plug into the formula and you get 5.0 times 10 to the minus 14 molar for hydroxide. Made me think about something. We actually made an error here, and I wonder if you caught it while I was doing this. So this is back on practice problem number 2. You really need 2 sig figs here. So that should have been a 1.0. Did I do it on this one also? Practice problem number 1? I did do the same error here. So since you had 0.10, this down here should be 1.0. So just go back and double check. Remember, this number has infinite number of sig figs, so you don't count it. So it totally depends on that number when you're counting your sig figs. All right, sorry. So problem number 1, make sure that you fix your sig figs here. Problem number 2, make sure that you fixed your sig figs here. And then problem number 3, double check your sig figs, because I did it right finally, and that's your answer for the OH. That's your answer for the H3O+. All right, so let's talk a little bit about pH. And so this goes with your reading that you had to do last night. So a 1 unit change in pH yields a concentration that changes by power of 10. So for example, if a solution has a pH of 3.0, its H3O+ concentration is 10 times more than something with a pH of 2.0. So if I go from 2.0 to 3.0 in pH, it's a 10 times difference in concentration. So the pH scale ranges from 0 to 14. Neutral, you should have read, is 7. Acidic is less than 7. Basic or alkaline is greater than 7. pH is unitless, and the formula to find pH is pH equals negative log of H3O+ concentration. And if you look at your if you look at your calculator, you have a log button on your calculator. And when you get into pre-calc, you'll talk more about what actually a log is. For chemistry class, you just need to know where that button is on your calculator and know that it makes a 10 times difference in concentrations. All right, so we are going to just solve problems again. So here's our problem. Consider this solution, and this is one that we did earlier. So back in one of the other practice problems that we did, in fact, it was number 2, we found that the hydronium concentration was 0.10. So you could also have figured that out this time. But H3O+ concentration for this acid is 0.10 molar. So you're going to use this formula to figure out what the pH is. So you are actually going to plug into your calculator, negative, push the log button, 0.10, enter. The number before or to the left of the decimal point is not a significant digits. Only the numbers after the decimal point are significant digits. So for example, pH equals 1.24. This number, not significant. These numbers are. So that one only has 2. 5.0. That number is not significant. That one is. That one only has 1 sig fig. So you try the last one. pH equals 14.11. How many sig figs does that have? You should have said 2. All right. So that's why in this one, I needed 2 sig figs because of this number. So then here, these zeros are significant. The 1 is not. All right, let's try another one. We have a 0.10 molar sulfuric acid solution. So back in that last problem, you found that this is the hydronium ion concentration. And so you are going to plug that into your formula. pH equals negative log H3O+ concentration. And so you're going to plug a negative log of 0.20, and you get 0.70 as your answer. All right, you try this problem. Pause the video and then start it. When you're done, I'll have the answer written up. Make sure you pause. So you first had to ionize your acid to figure out that you have 0.0050 molar of hydronium ion. And then you plug into your pH formula, and then you get that value. Remember, you need 4 sig figs, and only the numbers after the decimal point count. There is nothing to submit for the classwork today, but you'll need your notes to do your homework. Your homework is page 128 at the top, number 1, 2, 3, and 4, and page 129 in the middle A, B, C, D.